Hi friends, welcome back to our instrumentation series of Fundamentals of Instrumentation. Today we shall discuss about the typical applications of instrument systems. As we all know that the objectives of performing experiments are too numerous to be enumerated, but still certain common motivational factors for carrying out the measurements. Let's discuss as typical applications of instruments. So the first one is the measurement of system parameters information related to the system parameters. One of the important functions of the instruments is to determine the various parameters or information of the system or a process. In addition, they present the desired information about the condition of the system in the form of visual indication, registering, recording, monitoring, or suitable transmission according to the needs of the requirement of the system. In fact, condition-based system of operation is being used very widely these days in a number of situations, like the medical care equipment or medical care of patients or the maintenance of machine systems where shutdowns are costly or prohibitive. So that's where the measurement of system parameters information come into picture as the first application of the instrument. The second one is the experimental design studies. The design and development of a new product generally involves trial and error procedures, which generally involve the use of empirical relations, handbook data, the standard practices mentioned in design codes, as well as design equations based on scientific theories and principles. In spite of this, we sometimes have to resort to experimental design studies to supplement design and development work. Like an example, a design team of experienced aircraft engineers put in a number of years' effort to produce a prototype aircraft. The prototype is flown by a test pilot to determine the various performance operating parameters. The prototype test data is then used to improve further the design calculations, and a modified prototype is produced. This is carried on till the desired design performance is achieved. Thus, the experimental design studies quite often play an important role in the design and development of the new product or systems. The next one is control of a certain process or operation. Another important application of measuring instruments is the field of automation control systems. The measurement system forms an integral part of such systems, which in turn provides deliberate guidance or manipulation to maintain them at a set point or to change it according to a pre-program. The very concept of control system is a system that requires the measured discrepancy between the actual and the desired parameters. It may be noted, for an accurate control of any physical variable in a process or an operation, it is important to have an accurate measurement system. Further, the accuracy of the control system cannot be better than the accuracy of measurement of the control variable. To take an example, a thermostat fitted in a domestic refrigerator is a control device for maintaining the temperature in a specified range. Currently, automatic control systems are widely used in process industries like oil and gas, oil refineries, chemical plants, textile, whatnot, for controlling variables like temperature, pressure, humidity, viscosity, flow rate, and other relevant parameters. Further, they're also used in modern sophisticated systems like autopilots, automatic landing of aircraft, missile guidance, radar tracking systems, etc. So the next one is on the system simulation. We normally call it as simulation of system conditions. Sometimes it may be necessary to simulate experimentally the actual conditions of complex situations for revealing the true behavior of the system under different governing conditions. Generally, a scale model may be employed for this purpose, where the similarity of significant features between the model and the full-scale prototype are preserved. In such cases, analytical tools like dimensional analysis may also be employed to translate the experimental results on the model to the prototype. The lift, drag, and other relevant parameters of aerodynamic bodies are usually obtained by testing the models in controlled air streams generated in wind tunnels that simulates the flow conditions experienced by aerodynamic bodies. Information thus obtained is in the design and developmental of the prototype. So the next one is perform various manipulations. We have seen that in a number of cases, the instruments are employed to perform operations like signal addition, subtraction, multiplication, division, differentiation, integration, signal linearization, signal sampling, signal averaging, multi-point correlations, etc., etc. In certain cases, instruments are also used to determine the solution of complex differential equations in the design of robotics or other mathematical manipulations. A simple pocket calculator, which is a great example of a mathematical processing instrument to some extent. Furthermore, the modern large memory computers are instruments that are capable of varied types of mathematical manipulations. Then testing of materials, maintenance of standards, and specification of products. Most countries have standards organizations that specify material standards and product specifications based on extensive tests and measurements. These organizations are meant to protect the interest of consumers. They ensure that the material or products meet the specified requirements so that they function properly and enhance the reliability of the system. To take for an example, an aircraft engine is subjected to extensive endurance tests by the civil aviation authorities as per their specifications before it is clearly certified to be airworthy. Then we have verification of physical phenomena or scientific theories. Quite often, experimental data is generated to verify a certain physical phenomena. Coulomb postulated that the friction between two dry surfaces is proportional to the normal reaction and is independent of the area of contact. His hypothesis has since been verified experimentally and is now known as Coulomb's law of dry friction. In fact, such examples are numerous. Whenever a scientist or an engineer proposes any hypothesis predicting the system's behavior, needs to be checked experimentally to put the same on a sound footing. In addition, experimental studies play an important role in formulating certain empirical relations where adequate theory does not exist. And for example, a number of empirical relations for the friction factor of turbulent flow in pipes have been formulated till date by various investigators based on their hypothesis, in which numerical constants have been evaluated from experimental data. Furthermore, experimental studies may be motivated by the hope of developing new theories, discovering new phenomena, or checking the validity of a certain hypothesis which may have been developed using some simplifying assumptions. Then finally, we have quality control industry, which is quite common these days to have continuous quality control tests of mass-produced industrial products. This enables to discover defective components that are outright rejected at early stages of production. Consequently, the final assembly of the machine or system is free from defects. This improves the reliability of the product considerably. To take an example, a boilerplate has to undergo a number of quality control tests before it is put in actual practice. The various tests are X-ray examination of the plate for defects like blowholes, cracks, etc. Metallography examination for metallurgical defects, periodic strength tests of the samples, etc., etc. So the quality control is there in every industry, and this quality control department requires many metrological and meteorological department for different testing of the products, air quality control, environmental pollution control, etc., etc., where we need to obtain a specific quality control in industry. So that's all for today. Thank you very much for your time.